Conditional statements. Our objectives are to identify, write, and analyze the truth value of conditional statements, as well as write the inverse, converse, and contrapositive of a conditional statement. Well, why learn this? To identify a species of butterfly, you must know what characteristics one butterfly species has that another does not. Let's look at some vocabulary. Conditional statement is a statement that can be written in the form if P, then Q, where P is the hypothesis. It's the statement that's coming right after that word if. And the conclusion would be that Q. It's the statement that follows the word then. So if hypothesis, then conclusion is one way you can think about it. Let's identify the parts of a conditional statement. So we're going to try to identify our hypothesis and conclusion for each of these conditional statements. So, if a butterfly has a curved black line on its hind wing, then it is a viceroy. So the hypothesis follows the word if. So find the word if, and our hypothesis follows it. So a butterfly has a curved black line on its hind wing. Your conclusion is the part that follows the word then. It is a viceroy. So our hypothesis, a butterfly has a curved black line on its hind wing, and conclusion, the butterfly is a viceroy. Now this one's a bit tricky. A number is an integer if it is a natural number. So you want to start with your hypothesis, so find the word if. Well, here's your word if. So the hypothesis follows that word. It is a natural number. Your conclusion is basically the rest of it, because if you were to reorder this sentence and put a comma in there, you would have if it is a natural number, comma, then a number is an integer. So, a number is an integer is your conclusion. Let's try writing a conditional statement now. Write a conditional statement from each of the following. The midpoint M of a segment bisects the segment. So we need to make that statement into an if-then statement. Alright, now that you've had a moment to think about it, let's look at what we've got. Okay, so we have the midpoint M of a segment would be your hypothesis part, and then the bisects the segment would be your conclusion. So you're going to put an if in the front of one part, and a then in front of your conclusion. So if M is the midpoint of a segment, then M bisects the segment. So step one, just like we did before, identify which piece is your hypothesis and which piece is your conclusion, and then put your if and then in. Let's look at this Venn diagram. So we have tarantulas and spiders. Alright, well, are all spiders tarantulas? No. But all tarantulas are in fact spiders. So, if an animal or it is a tarantula, then it is a spider. Okay, well, a conditional statement has a truth value. It's either going to be true or false. So, it is false only when the hypothesis is true and the conclusion is false. So once again, the only time your conditional statement is false is if the hypothesis is true and the conclusion is false. Let's look at a few examples. If today is Sunday, then tomorrow is Monday. Well, when the hypothesis is true, the conclusion is also true. So Monday follows Sunday, so in this case, the conditional is true. In B, we have, if an angle is obtuse, then it has a measure of 100 degrees. I like to think of it this way. If you're dealing with something that's an obtuse angle, can you think of a counterexample to this statement? If an angle is obtuse, then it has a measure of 100 degrees. Well, does an obtuse angle have to be exactly 100 degrees? No. Okay? If an odd number is divisible by 2, then 8 is a perfect square. Well, the hypothesis can't possibly be true. And remember what we said previously. The only time a conditional statement is false is when the hypothesis is true and the conclusion is false. Well, your hypothesis doesn't even make any sense, so the statement is just going to be true. You can think of it this way. If you had trouble with C, this may help. If pigs can fly, then I am Snow White. Well, pigs can't fly, and I'm definitely not Snow White. So the whole thing just doesn't make sense, so therefore it's just going to be true. Because if we're not in reality, then sure, it's a true statement. Okay, let's look at negation. The negation of a statement P is not P. So you can write it as like a little squiggle and then P. The negation of a statement, so let's take M as the midpoint of AB. The negation of that would just be M is not the midpoint of segment AB. So the negation of a true statement is false. The negation of a false statement is true. Basically, negation just has the opposite value because you're putting not in front of it. Or if it had the word not, it suddenly doesn't have that word in there anymore. Looking at a few examples might help, but first let's look at the converse, inverse, and contrapositive. So you already know that a conditional statement can be written in the form if P, then Q. So P, arrow, Q as symbols. The converse would be exchanging your hypothesis and conclusion. So your converse, you're simply going to just flip your conclusion with your hypothesis. So it would be if Q, then P. Now this is when your negations start happening. You have inverse. The inverse is the statement formed by negating your hypothesis and conclusion. It's in the same order as your conditional statement. So if not P, then not Q. So to repeat those three, you have if P, then Q. The converse, just flip your hypothesis and conclusion. So if Q, then P. And your inverse, you're going to go back to your original order and just throw a not in front of things. So if not P, then not Q. Now, your contrapositive is the statement formed by both exchanging and negating the hypothesis and conclusion. So, you're going to essentially think of it as looking at your converse and then throwing a not in there. So, if not Q, then not P. Let's look at an example. Write the converse, inverse, and contrapositive of the conditional statement. Use the photos to find the truth value of each. If an insect is a butterfly, then it has 4 wings. Okay, so if an insect is a butterfly, so an insect is a butterfly is your hypothesis. Then it has 4 wings. So after the then is your conclusion. So your conclusion is it has 4 wings. Okay, so using that idea, let's try to find the converse. Remember, converse is when you simply flip your conclusion and your hypothesis. So, if an insect has 4 wings, then it is a butterfly. Well, this would be a false statement because a moth can also have 4 wings. Alright, well, let's try the inverse. So the inverse was when you simply put a not in front of both pieces. Alright, so if an insect is not a butterfly, then it does not have 4 wings. Well, that statement is false as well, because once again, a moth can have 4 wings. Alright, let's look at the contrapositive. The contrapositive deals with flipping your hypothesis and conclusion and negating. So, if it does not have 4 wings, then it is not a butterfly. And, well, that would be true, because it can't be a butterfly if it doesn't have 4 wings. Alright, well, let's look at logically equivalent statements. Logically equivalent statements are related conditional statements that have the same truth value. So, a conditional and its contrapositive are logically equivalent. So they're either both going to be true or both be false. Same with the converse and the inverse. So the converse and inverse are logically equivalent statements. Let's look at a table that might help you understand this a little better. So we have a conditional, converse, inverse, and contrapositive of the statement, if the measure of angle A is 95 degrees, then angle A is obtuse. Well, we know that that is a true statement, but as soon as we flip your hypothesis and conclusion, you can come up with a counterexample for that. Same with if you were to simply negate your hypothesis and conclusion. So therefore, they have a truth value of false. Notice, they have the same truth value, and then your conditional and your contrapositive have the same truth value. Okay. The converse of a true conditional is not necessarily false. All 4 of them can be true, and all 4 of them can be false. The only thing that has to happen is your converse and inverse have to be the same, and your conditional and contrapositive have to be the same. And that will conclude our lesson on conditional statements.